All right, I think we can go ahead and kick this off. Um, First of all, welcome everyone. Just want to go over a few housekeeping items. Today's webinar is going to be recorded. If you have any questions, please put them in the Q&A. We'll try to monitor the chat, but please put them in the Q&A if possible, and then we'll go over them at the end. Today, Clever is going to present about analyzing logs with ClickHouse. And with that, let's kick this thing off, and over to you, Jake.
Hi, Jake. Thanks for introducing us. Again, this is our presentation on analyzing logs with ClickHouse here at Clever. My name's Jake, and I'm joined by Tanmay. We are both senior software engineers here at Clever on the infrastructure team. Here's a brief agenda of what we're going to go over. We're going to go over our problem motivation for choosing ClickHouse for our log solution. And then we're going to go into three things that made ClickHouse work for us, such as our schema design, resiliency, and query experience. So just a bit of background on Clever. We are the leading identity platform for education with over 29 million teachers at around 77% of US K through 12 schools use Clever to power the learning experience. And that kind of leads us to our first problem. We have a lot of logs. We have 400 services and workers on AWS Fargate, and we also have 200 Lambdas generating about 150 terabyte of logs per month. And before ClickHouse, they were all being sent to Datadog. And once they're in Datadog, we only index about 10% of logs with the 3-day retention policy, and with the rest of the logs in AWS Athena. And this dual brain system proved to be very confusing for engineers. A lot of them go, "Where's my log?" because we dropped the bug logs, or they say this error log started 3 days ago, but in reality it started much longer than that. And then if they wanted to look at a trend over the 30 days, it would be very difficult to do that in Datadog because it's only 3 days, and they'd have to go to Athena for that. So that leads us to our first requirement for a new logging solution, which would be one place for all logs for 60 days. And this can be challenging for some observability platforms in terms of costs. So we wanted something that was competitively priced and highly available, and ideally in a managed platform so that we don't have to bear that maintenance overhead. And lastly, we wanted this logging solution to be easy to use, just so that our engineers who are too familiar with other types of SQL or anything like that, they just can use something very straightforward, similar to Datadog at a similar performance. And that leads us to our first thing, schema design. This is a pretty interesting topic in the ClickHouse community. There's lots of different ways to store logs in ClickHouse. A lot of our logs are structured, are JSON, so we'd like to have a way to index them at write time instead of having to parse them at query time. And there's a bunch of different ways to do that, such as extracting fields into their own columns, or using a map type, or you can just store the JSON as a string and just query it at parse it at query time anyways. And there's also indexes to consider, such as indexes on columns and map values and keys, the types of indexes and the size of them, and what most important thing is primary key and order by. This determines a lot about your performance, and wrapping that up into a very easy to use query experience. So just jumping right into our schema, I'm just going to go block by block. So first we store the timestamp in both seconds and milliseconds precision. That gives us pretty good performance when we filter on timestamp, and then we just filter on the timestamp and then milliseconds to filter within the timestamp range and then get that just milliseconds range. And this gives pretty good performance and compression speeds. Next, we extract some of our fields from a log, such as level and service. And these are very commonly queried fields we found. So we extract them from a JSON string. And as you can see here, we actually went with a hybrid approach in terms of storing the logs. So we store the fields of the log as a JSON string and a map. So in the attributes map, we store anything that's not extracted. So you won't see the level or service attributes in this map. And next, we have all sorts of indexes, and these are just the few I picked out. So for instance, we have a min-max index on timestamp, which seems redundant, but I'll get into why we need that here in a bit. Next, we have a lower body index on the body with the token BF. That gives us case insensitive regex on the body with granularity 32. We chose a higher granularity here, which was good balance between performance and index size. Next, we get a Bloom filter on the map keys, and then a token BF filter on the map values. Similar to the body, we did some internal benchmarking to determine that 32 was a good granularity size for our use case. Next was our partition, pretty straightforward, just a to date. And paired that with our TTL of 60 days, along with TTL only drop parts, that gives us pretty good performance for dropping entire partitions. Next is our primary key and order by. This is where it gets pretty interesting. So we store records in reverse order of the timestamp, and that gives us pretty good performance since most log queries are going to get the last few records instead of the earliest records for some range. So we use the negative to Unix timestamp on the seconds and milliseconds precision. And then going back to the timestamp min-max index, this still allows us to use a normal timestamp query where clause without having to invert it to use it the primary key index. Lastly is the TTL and settings. So right here we have index granularity, TTL and drop parts. I like to call it the cache populated by fetch here because this is a special ClickHouse cloud setting which allows inserts to one replica to be redistributed among the other replicas so they share a similar query cache across all of them. So a select query to one should have consistent results, consistent performance at least with the other ones. Next, I'm going to hand it off to Tommy to talk about our resiliency portion of our ClickHouse system.
Thanks, Jake. Yeah, you can go to the next slide. Yeah, so observability is one of the most important parts of any system. That means it must be resilient to outages and highly available. So to achieve resiliency, we had three different requirements. The first was we wanted to separate production and dev logs. This was to avoid contention, for example, like a dev load test causing like a spike in log volume and bringing down production logging system. We also wanted a way to test changes to the logging pipeline without impacting production. Second was to write logs to multiple regions. As Clever runs in multi-region, we also wanted our logging system to be multi-region. So that, like if ClickHouse is down in US East 1, or there's some connectivity issues in US East 1, we don't just lose all logs in US East. And then finally, we wanted our entire infrastructure to be managed in infrastructure as code. And we also wanted the schema management in code so that this system is easily reproducible. And in case of eventual international expansion, we can just run like a few command line things and it's up and running. Next slide, please. So this is what our setup kind of looks like. It looks a little complicated, but it's really straightforward. We have three different ClickHouse services running. One for production logs in US East, one for production logs in US West, and one for all of the dev logs. To keep the query experience great, we also want to query all logs from a single place. So we make use of the remote secure table function in ClickHouse and merge tables. So that way we have created remote secure tables in both of the production ClickHouse services, and then we have created a merge table on top of that. Oh, this macOS thumbs up came up. But yeah, so, and then we have our query experience, load balance requests across the two services. In case of an outage, we can easily stop and redirect all reads to only one of these services. We can also redirect all writes to only one of these services. So that way we are more resilient to outages in a single region. Yeah, next slide. So yeah, this entire system is managed in GitHub repositories. The ClickHouse services and the auxiliary things like secrets or KMS keys, they're all created using Terraform. And the schema is managed in Goose with like incremental change files in both SQL and Go functions. The Go functions are useful in pulling credentials so that we don't have to store plain text passwords in GitHub. And it also helps us easily write statements to dynamically create resources like the remote tables. Yeah, so final section is the query experience. So the query experience also has like three main requirements. We want something that is similar to Datadog. so that it is easy for our engineers to ramp up to this new system and there's no steep learning curve. Most of our engineers also don't use SQL on their like day-to-day work. And ClickHouse sometimes has like a non-standard schema, which might make SQL queries more difficult. Finally, we could have used the Grafana ClickHouse plugin, but because we don't use OTel logs in our system, and we have like a non-standard schema, we couldn't use that. But we still wanted to use Grafana in some way because our engineering team is very familiar with Grafana. So for this purpose, we built QLayer, which stands for Query Layer, which implements a subset of Grafana LogQL to translate LogQL queries to ClickHouse. More complex queries can still be made in SQL, but our engineers can always request like improvements to LogQL. There's a few backlog tickets we have to implement things like sort or count distinct. Yeah, so we'll do a demo of that in a bit. But yeah, with this entire system, everything Jake talked about and I talked about, we see a compression ratio of 10x, and we see an increase in log by 200 times. These logs are, easily accessible to all engineers. They get access to all 60 days of logs. And there's only a single place for them to look at logs. They don't have to think about whether I query in Grafana or I query in Athena or Datadog or whatnot. And all of this came at a 0% increase in cost, which was one of our key requirements. Yeah, and I'll pass it back to Jake to do a quick demo.
Yeah, I'm gonna just migrate to a quick demo real quick. I only have about a minute to show off what we have in terms of Claire. Let me just get that set up real quick. Yeah, I guess I can just do this. Wow, that didn't work, of course. Yeah, just give me a second. Let's do some questions and I can do the demo at the end.
Awesome. The first question that we have is, what is the difference between body and JSON raw? I assume that the main log message is stored in the body.
So for most of our logs, yeah, the JSON raw is analogous to the body, but sometimes, in most third-party services we have, they'll actually have a log body and then we attach a few labels to them. So the original log line would be the body. Otherwise, it would be that entire JSON string.
When you query the schema, do you always fetch all fields, or do you have a way to fetch only some fields and then expand a row if the user wants to see more?
Yeah, so that's what's nice about the JSON raw field is that it stores everything else that even things that are already extracted into the main schema, so we don't have to do select star, which is can impact the performance of ClickHouse. So we just use the JSON raw and the body along with the timestamp to get the top level information for a log.
Awesome. And then has the inverse time ordering made a big difference for you? I'm wondering because we've been storing our logs in forward time order.
Yeah, so it has made a pretty big difference. It's been about a 10x speed up in our queries. I believe, yeah, I believe more modern versions of ClickHouse are better at doing reverse order, reverse order read in order optimization essentially. But at the time, it was an 8 to 10x speed up.
That's great. And then what projection specifically do you use for log volume?
It's just a simple select count on things like service, title, and environment, the region, and things like that. And then we group by seconds and all those other columns for that.
Awesome. There's a few that came into the chat. Get to those too. I'm curious how much effort / staff was required to maintain Datadog versus now required to support ClickHouse.
I would say like the staff is the same. We haven't added more engineers onto the team, but it definitely takes a lot more time. example, or one of the things we valued, that's why, is using ClickHouse Cloud instead of self-hosting this entire system. So we still don't have to think about scaling or running upgrades. The biggest lift here was actually building out the system. Now that it has been live for a couple of months, we rarely have to touch anything.
Thanks for that. I guess a follow-up item that I have before I get to the rest of the questions, um, being that it seemed like there was a little bit of overhead involved in the beginning of this, for someone just getting started with ClickHouse, what recommendations would you make?
Can you repeat that question again?
Yeah, so it sounded like there was a lot of overhead in the beginning of getting started with ClickHouse. So for folks on here that might be new to ClickHouse, what recommendations would you make just for getting started with ClickHouse to maybe accelerate the process, some lessons learned?
Yeah,
Yeah.
I think that's a good question because I read so much documentation in the beginning. But I think, of course, the one thing I always do is just spin up ClickHouse locally and try it yourself. And that's the one thing that really accelerated my learning is just even inserting random records into a table or even backfilling some logs into a ClickHouse cluster helped me a lot in terms of trying to decide what schema works best.
Yeah, I was also able to learn a lot by just running things locally. I think once you start building out the system, it's always a good idea to do dual writes. We were running Datadog and ClickHouse simultaneously, incurring a lot of costs, right? Like our logging costs were 2x for that amount of time. But that helped us kind of guarantee that we are going to a system that is not worse than what we have today. So that really helps.
Awesome. There's another one in here that was pretty interesting. So it says, what does 200x increase in logs really mean? You started to ingest more because dot dot dot. And I see that was
Uh,
answered by, I'm assuming, a colleague, but I'll let you touch on that really quick.
Right, yeah, exactly like what Chris said. We never we're not generating more logs. In the pre kind of ClickHouse world with Datadog, we were indexing only the error logs, and we were indexing only like a small percentage of our info logs, and we were not at all indexing our debug logs. If engineers wanted to, for some reason, look at all of the info logs or wanted to look at the debug logs, they would have to use AWS Athena and write some SQL queries. So the logs were still there. They were just going to, like an archive in indexed by Datadog. Now you can think of them like all indexed by ClickHouse. Um, yeah, I hope that answers it.
Yeah, I think that answers that question. I mean, even from my end, working with hundreds of customers at this point, it's pretty common to see folks, one, stop sampling their data, and two, increase the retention on their data on their data volumes, right? Which increases the amount of logs stored, but you still have a decrease in storage size because of the way that ClickHouse compresses data. So glad you guys saw that as well. There was. Let's go back to the Q&A here to get to some of these folks. How did you go about tuning the attributes column on your table? I see that map key values are low cardinality, but tag values were unbounded.
We didn't do too much tuning on the attributes column because we just went with the assumption that low cardinality value keys are the way to go, and then the tag values were unbounded. Just they weren't low cardinality enough. In terms of indexes, it is a bit tricky. You might have to play around with queries to actually do, a match on the map values array or something like that to see if it contains some item or something along those lines. But in terms of tuning, I think there's a question about how did we exactly benchmark. So what I did was create a separate index for each granularity size or whatever, or bloom filter size or whatever. And then there's a ClickHouse setting, you can ignore indexes. And I just changed that list of indexes to ignore depending on which index I wanted to test. And I just looked at granule sizes. And I was able just to easily create new indexes on the same table without inserting into a new table or anything like that.
Awesome. Do you also index on trace ID for querying logs unique to a specific trace or a comparable identifier?
We do have some indexes like that are probably a bit higher granularity, but yes, we do have some indexes like that.
Did you evaluate any alternatives that also use ClickHouse under the hood before building your own in-house solution? And also, I'd like to add to that how you guys came across ClickHouse. I would love to know.
Sure. So any ClickHouse-based solutions we deem for just too expensive for storing the entirety of our logs. And we came across ClickHouse because of so many observability use cases that came out of ClickHouse recently. Like the state of SQL support was pretty helpful. And I like this, I would love seeing, future support for PromptQL metrics and also the native JSON type, which you probably get away with now instead of using the map, things like that.
Awesome. Is
There's a
150
question.
Oop, sorry, go ahead.
There's another interesting question, which is the hotel aggregators in the architecture diagram. So the way we are writing our logs is that we have we run a Fluent sidecar across like all of our Fargate services, and the Fluent sidecar is writing to this hotel aggregator, which is really just using OpenTelemetry, like hotel corrector, and then that is what's writing all the logs to either the US East or US West ClickHouse service.
Yeah, and to expand upon that, I see another question about the exporter, is that we did write our own ClickHouse exporter as long as with some processors to help with our unique schema.
Great. For the 150 terabytes per month compressed data, or is that, for the 150 terabytes per month, is that compressed or uncompressed first? And then
That's uncompressed, yeah.
it's uncompressed. Okay. And then what computer are you using to handle the data?
What we can say. It's actually been quite a bit, but we found that ClickHouse is very good at ingesting, but when it comes to query times, we add more compute for that, just because some people might write some crazy queries. So we actually handle, like our current ClickHouse compute size could probably handle 4 times the amount of our ingestion, but we just lean more towards query speeds for our engineers. So we use a bit more compute towards that, the ingestion.
Yeah, and to add on to that, I think ClickHouse also like supports like quotas. So that is something we're going to look into. Is like, could we, limit queries that are using a lot of memory, but that's just not been a priority right now.
Perfect. How do you find proper settings for your Bloom filter based indexes? Notice that sometimes the analysis part takes a long time. How do you choose n-gram token size?
Yeah, so with Ngram, it's easier than something like Bloom filter, because with the Ngram you can just multiply the size times the granular. What you do is multiply the size of the filter in token bytes times the index granularity divided by the granularity of that specific index, and then you can kind of guesstimate how big that index size should be. It should probably keep that around less than 1 GB for the entire table. So that's what I kind of did, and also played around with creating huge Ngram indexes, divide that by 2, and just kind of do like a binary search along a spectrum of powers of 2s to find that good balance.
Great. Sounds like you did a lot of tuning and experimenting on your own, which is great to see. If you were migrating from Splunk Enterprise, this is an interesting one, on-premise on AWS to a similar do-it-yourself ClickHouse solution, would you expect to be able to lower costs? Any other challenges? And did you look at OpenObserve?
So I'm not too familiar with Splunk Enterprise or their on-prem AWS solution, but I suspect that it'd probably be cheaper just because you won't be able to get Splunk support for your ClickHouse stuff, right? So you're incurring some of that cost and overhead. And when I was comparing multiple observability solutions, ours were just much, much cheaper on paper, right? I did take a look at OpenObserve. It just didn't fit our requirements because we would have to self-host the ClickHouse cluster itself. And that was with some other solutions as well.
The next question I think fits great with like a demo. So maybe we can just, since we're at the last 2 minutes.
Yeah, let me share what we have for that. Okay, so this is query layer. It's really just really low-key LogQL with a service in between our ClickHouse stuff. So we're looking at logs in ClickHouse. And to kind of show you what it looks like, we have our log volume graph that is backed by a projection for most queries. You can also see individual logs and their attributes, and this is just populated from the JSON raw along with like the timestamp and the body of the log. So let's start with some queries. We have some materialized views to help with like some IntelliSense style autocomplete. So we can just do something like that and see what combinations of keys and values and whatnot. And the label browser is supported to an extent for this. You can see all of the columns that are extracted from the JSON fields, but only some of them support values because of the materialized view. So for instance, workflow ID probably doesn't have anything, but title will have something, for instance. And you can get a lot out of our LogQL implementation, such as aggregations, both unwrapped and typical some count over time aggregations as well. We also did something interesting I can show off to support nested queries. So maybe querying Claire would be better for this case. So you can see these are my own requests right now. Let's see, I have this summary status dot exec time, and I want to see exec time that's over 0.10 seconds, for instance. So I can use the JSON processor. This is more of a way to extract nested attributes into top level columns. So I can do exec time equals dot using the JSON path syntax from ClickHouse's function. And that will do is, let's see, for which type of queries again? Log range queries, we'll see that exec time is extracted into there. And then we can filter on that using your typical functions like that. I think that's about it for our time. Unless everyone have time for some more questions.
Nope, I think we're at time. Jake, Tomei, this was fantastic. Thank you for sharing this with us and with the community. Thank you everybody that's been staying on this. Just one last item. So we are offering a free training tomorrow around observability on ClickHouse. So feel free to sign up for that and join. And with that, thanks guys. Have a good day.
Thank you.